This is a video about the coolant cap, how it works and how you can turn it into a 1.2 bar cap vice the 2 bar that comes standard. A couple of things before we start. This is the cap itself here. You can separate it out into two pieces like I've done there. On the inside of the top piece of the cap there are 4 little clips that the top of this just pushes straight down into. You can pull that apart. The clips here are actually quite aggressive, and the best way I've found to get that out is to actually get a large screwdriver and push it in there and then actually just lever it out like that, and then you can just pop that part out. Depending on the variety of cap that you've got, because there are lots of different types out there, this can actually be quite easy to pull out, and sometimes they can be a real pain, so just depending on what you've got. What I've done with these, I've actually sort of burred off the little barbs here just to make that a little bit easier to pull out the next time. The cap itself, there's obviously those two pieces. This bit here, which is the pressure relief valve part, is the bit that actually does all the work. The top here just holds everything on. This bit would actually work out fine. You can actually just sit your finger on the top and hold that down. As long as it gets held in place, it actually does what it's supposed to do. But obviously that just holds it in the top. The valve itself, there are a couple of parts to it. The first thing is we've got a couple of O-rings here. They're different sizes. The lower one's a little bit smaller, it's about a little smaller outside diameter than the top one here. They obviously slide down in the throat here, and the throat is slightly conical, so this slots down nicely. There's also another seal here which sits in this seat here, and from what I've seen, it looks as though it's actually the 2 O-rings along here that actually do most of the work. It actually seal along the throat there. At the top part here we have the pressure relief valve, and you can see the spring that's actually inside there, and there's actually the valve itself is actually down in there, and you can actually get a pick tool and stick that down there and actually lift up. I'm not sure if you can see this, but you can lift up the valve just to check that it's actually working okay. To pull this apart is relatively simple. The couple of methods I've found, you can either get a pick tool like this and just jam it down in here and leave it out, but the one that I've found is probably a little bit easier. Just get a really big flathead screwdriver, jam it in the gap there and just twist it around and work it around, and eventually the bits will all pop apart. A couple of points to that is that this will be under quite a lot of pressure. The spring of here I've actually shortened to make it into the 1.2 bar cap. The spring normally is longer than this. It's under a fair bit of pressure, and keep your finger over the top of it, otherwise it'll spring to the other side of the shed and you might never see it again. Also, depending again on the type of valve that your type of cap that you have, the brand that it is, sometimes these are quite easy to pull apart, sometimes these are quite difficult and they might need a bit of work. When we pull it apart, we've just got that top piece there, which is just the clip which holds it in place. You've got the spring. Now the spring normally is longer than that. It comes to about there, it's about a centimetre longer. The standard length is around 31.5 millimetres long. This one I've shortened to create less pressure down on the valve itself. This is the valve, and there are a couple of sides to it. There's the major side here, which has this seal around the outside. Again, depending on the cap variety you've got, these can be, that literally looks like a Teflon seal, but I'm not sure. It's quite soft and pliable. These are, from what I've seen, the good ones. I've seen others that actually have a sort of thicker black normal rubber type seal, and they actually, I found those can sometimes stick to the seat here and you really have to pry them apart, so the pressure relief mechanism just does not work at all, and I've had systems over pressurised as a result of that. So that seal there will sit down on the seat, and it's that spring pressure which creates the pressure relief mechanism. On the other side of that is this small spring here, and that has very little tension at all, and all that does is allow air to go into the system when it cools down, so you don't end up with a partial vacuum inside, just so it can equalise inside to outside pressure. But the main part of it that we're talking about is this seal here. So when you pull this apart, all we're going to do is shorten this spring to get it to create the right amount of downforce on the seat down here, so then it relieves at 1.2 bars instead of the 2.0. Putting this back together again is pretty simple. You're just going to plonk the valve down in there. With the shortened spring that I've done, you can see there are two edges of it. The original spring at the start had the flattened end on both ends, and obviously I've just cut one end off, and what I'm going to do is put that flattened end, which is the original part, down against the valve so that gives nice even spring pressure, and then I'm actually going to put that pointy bit there. Even though it compresses and it's not too much of a problem, I'm actually going to put that into that top piece there. So that just goes in, you push that in place, and then you just push the cap together, and then you can just shove that straight into the expansion tank. This is my setup for testing of the actual spring pressure. What I've got, just some kitchen scales. They're actually reasonably accurate, within a few grams. I've got some plain pieces of timber on either side that are exactly the right height, so when I actually press this down, it will actually compress this spring to exactly the right amount, which is at 13mm gap in here. It's actually 14mm with the cap on top because it actually sits a millimetre further down, but the spring gets compressed to about 13mm, and then we'll see what pressure it actually, or what weight we actually get on it. And you can see that gives pretty close to 3 kilograms. So that's 3.01. I actually tested this with a hot spring, so I boiled water, sat in it, and immediately tested the spring weight then that I was pressing down, and whilst it was marginally less, there really wasn't much in it, within a couple of percent. So I'm happy that if you do this with a cold spring rather than a hot one, which is going to be when it's inside the cooling system, it's really not going to make that much difference at all. So all my plan is now is to shorten this spring to change that to a more appropriate number. This is the spring after I've cut it down. Like I talked about earlier, the height from the bottom here to the top of that tip that we've cut it to is 21.5mm. To calculate to get the correct pressure on the way down, originally it was about 3 kilograms, which gave us around that 29 psi, which is that 2 bars of pressure. Now we want to take it down to about 1.8 kilograms. And if we get that 1.8 kilograms, that should be that 1.2 bar pressure that we're trying to relieve the reservoir at. And there we go. So that's about 1.8 kilograms, which is exactly what we wanted. This was the test bed that I used to check that the pressures were actually correct. It's an old expansion tank that I pulled out of a car a number of years ago, and I kept. It was actually still working fine. It wasn't cracked. I just changed this particular expansion tank on spec because it was getting a little bit old. I chopped the bottom off it just to get rid of the holes, and then just sealed it with a piece of aluminium. And I put in a car valve at the top here, and I've also sealed the pipe inlet connection there, so I can pump this up with compressed air. I can then allow the air to escape from here and see what pressure it actually relieves at. I set this up with my air compressor to allow just probably about 30 psi of pressure to go into the system, so it would pump up reasonably slowly, and then as I could actually hear it start to relieve the pressure, to then stop the pressure going into it and just allow it to settle down to see what it would settle down to. And basically it settled down to pretty much exactly 18 psi, which is exactly what I wanted. So I was pretty happy with the relief pressure that it relieved to, which was great. And I've used this for a little while in my car now, and it works perfectly well.